Hello everyone, welcome. Today we'll be talking about limits that have piecewise functions in the limit problem. Let's get right into this. Okay, so in this problem we have the limit as x approaches 1 of f of x, where f of x is defined to be x squared plus 1 whenever x is less than 1, and 3x minus 1 whenever x is greater than or equal to 1. And if you're curious how that looks like graphically, this is what the function ends up looking like. So on the left here, left of x equals 1, we have the x squared plus 1, and to the right we have the 3x minus 1. So the way that we go about solving these types of problems is actually taking advantage of the property of limits, that if we have the left side limit equaling the right side limit, then the limit equals both those values. So actually let's just do that. Let's just dive right into that. So we'll have here the limit as our variable x approaches 1. Let's start with the left side first. So it's going to be f of x, but f of x on the left side, as we saw before, is just x squared plus 1. So that's what we'll write here. It'll be for x squared plus 1. And here, well, I mean, there's not really any special treatment that we have to give this 1 from the left side. It's really just a 1. And so this limit ultimately just ends up becoming a 1 squared plus 1. And then that we can very easily see is just a 2. So the limit of f of x, whenever we take the limit from the left side, is just 2. Great, so now let's try the right side. So we'll have the limit as our variable x approaches 1 from the right side. So here if we look at the definition of f of x on the right side, whenever x is greater than or equal to 1, well that's just 3x minus 1. So that's exactly what we'll take the limit of. That will be 3 times our variable x minus 1. And again, there's nothing really special about this one from the right side now that we've converted the function into just these very simple terms. We can just plug in the 1 directly. So this just ends up equaling 3 times the 1 that we were looking at before minus 1. And I'm sure you can figure out the math in that. That is just 2. And so we see here that our left side limit is equal to 2, and our right side limit is equal to 2. Well, by golly, that tells us too that, no pun intended, the limit as x approaches 1, I'll just kind of write all that in purple, of f of x should also be equal to 2. Let's take a look at this problem. So we have the limit as x approaches 0 of f of x, where f of x is equal to 5 cosine of x whenever x is less than or equal to 0, or it's x plus 2 squared whenever x is greater than 0. Let's try the same strategy as before. Let's take the left side and right side limits for this. So we'll have the limit as x, and x is going to approach 0. I'm going to start from the left side once again, and that'll be of f of x. So f of x right there. Okay. So again, our definition for f of x whenever we come in from the left side, well, that's whenever x is less than 0, essentially. It's really close to 0, but it's essentially 0. So we have to use the definition 5 cosine of x here. So this ultimately ends up becoming a 5 cosine of the x that we're looking at. So again, at this point, we can just very simply plug in the 0 directly. There's nothing special about this 0 from the left side now that we just have a basic function. And that becomes 5 cosine of 0. And we know that cosine of 0 is 1. So that's a 5 times 1, which is just equal to 5. So our left side limit is equal to 5. Now let's try our right side limit. So the right side limit would be the limit as our variable x approaches 0 from the right side. And again, here is where we have our definition for x on the right side. That's just x plus 2 squared, because that's when x is greater than 0. So we'll have this x, and then we're going to add 2 to it, so it's plus 2 squared. Great. Again, there's nothing too serious we have to worry about when we're looking at this 0 from the right side. We can just plug that in directly. So when we do, we get that 0, then we add the 2 that we had before, and we square all that. And 2 plus 0 is just 2, and a 2 squared is 4. So we see here that our left side limit is equal to 5, but our right side limit is equal to 4 when we approach 0. So therefore, our final limit does not exist. So that shall be our final answer right here. The limit as x that we're looking at approaches 0 of f of x, the x right there, well, that is going to d and e. And finally, we have this problem. So it's asking us to find the value of k for which the limit is as x approaches 1 of f of x, where f of x is defined to be 2 e to the x minus 1 minus 3 whenever x is less than or equal to 1, and kx plus 5 whenever x is greater than 1. We have to find, once again, the k for which this limit exists. So the approach is similar to what we've been doing before, except this time, instead of checking whether the limit exists, we force it to exist and solve for the value of k where that works. So let's force them to exist right now. So if you recall, before I start writing, that if we have two one-sided limits equaling each other, then the limit itself will be a certain value and it will exist. So we can have the limit as the x here approaches 1 from the left side, that'll be of f of x, and we force that to be equal to the limit as our variable x approaches 1 from the right side. And that will once again be a limit taken on f of x. Well, great, we have that forcibly being made equal to each other, but now we have to substitute in what our definitions of f of x are into each of these limits. So when we do that, we end up with the limit as our x approaches 1 from the left side. I'll kind of write all that in purple there. And f from the left side is this f right here. So it would be 2 e to the x minus 1 minus 3. So that's a 2e to the x minus 1 and all that minus 3. And that has to be equal to the limit as our variable x approaches 1 from the right side. And then we just plug in our definition for the right side. So that's kx plus 5 right there. So that will be a kx plus a 5. Perfect. So now we just kind of plug in the 1 into both of these. There's nothing special that we have to worry about with the one-sidedness nature of the limits. So when we plug in a 1 into the 2e to the x minus 1 minus 3, well, we just get a 2e to the 1 minus 1 minus 3, and that will be equal to the k that we were looking at before that we're trying to solve for times 1, and all of that is going to have a 5 being added to it. So at this point, it just becomes algebra to solve for everything. So the 2e to the 1 minus 1, that's just a e to the 0. So e to the 0 is 1. 2 times 1 is just a 2. So a 2 minus 3 is equal to our k that has a 5 over here. And then, as you can see here, this 2 minus 3 simplifies to a negative 1, and a negative 1 minus 5 just lets us know that our k value should be equal to negative 6, because negative 1 minus 5 is negative 6. We are now all done. Thank you for watching, and have a fantastic day.